Hi, I am Hutson Meeks, and I work with the Solutions Engineering team at BMC Software. This video covers event correlation rules in BMC ProactiveNet Performance Manager, also called BPPM. Now, before we dig into the details, let's go over a few basic concepts regarding event processing within BPPM because you have multiple capabilities. BPPM supports three methods of event correlation: probable cause analysis, policies, and the event correlation rules. Probable cause analysis requires no coding, and it leverages the probable cause analytics algorithms. Policies, on the other hand, are based on templates and do require some manual configuration, but no coding. Event rules require coding and knowledge of what's called MRL in the product. And that is what this session is about. So let's dig into the details.
This video is intended for users who are already knowledgeable with BMC's event management solution and have some experience with master rule language, also called MRL. We are specifically focused on creating an event correlation rule in this video. If you do not have experience with MRL, go ahead and watch the rest of the video. I'm going to provide a short review of the basics along the way. This diagram of the rule phases illustrates the order of rule processing in the event manager. As you can see, the correlate rules are processed about halfway through the phases. At the correlate phase, we expect filtering and other event pre-processing to have been completed for the events that we want to correlate. Now let's review the events we're going to correlate. For this simple exercise, we are going to correlate critical status events for two different Windows services when those services go down. The services I picked for this example are the Windows Remote Registry Service and the Windows Update Service. The correlation will generate a single new event when these services go down. Now let's dive into the code and see how this is actually done. Here we see the directory structure that contains the knowledge base for the event processing cell. The directories under the KB folder contain the event classes, data classes, and other configurable structures for this cell. The rules folder contains all the rules in MRL code, and they can be edited. This install is mostly out of the box. The only file I have added is the file named correlate_svc_down.mrl, which contains the example correlation rule we're going to review. Let's review the structure of this file. Correlation rules are based on cause and effect relationships. This assumes that an event is the cause of another event, or that the events at least need to be related. And it's not limited to just two events. You can correlate multiple events. The word correlate that I have highlighted here defines the rule type. The correlate SVC down string is simply an arbitrary value that I assigned as the rule name. Obviously, it's important to use meaningful names. The section you see here that has patrol EV in it defines the event class for the events that we want to correlate. Now in this example, we're just correlating patrol events to patrol events. However, you're able to correlate events from different classes and different sources across the managed enterprise. So you're not limited to just correlating the same types of events. The $first and $second values that you see here are variable names that the events I wish to correlate will be put into for comparison purposes. The words first and second are simply arbitrary values that I assigned. Obviously, the naming would be important, and they're referenced further on in the rule definition that you see below. The where, within, and when clauses define the selection criteria for the events that I wish to correlate, because I don't want to correlate all patrol events. I'm looking only for specific patrol events that are related to the services that go down at the same time. And in our case, as you saw earlier, we're looking at remote registry service on Windows and the Windows Update service, which is defined by this string you see here. The within clause indicates that we care about these events if they exist in the cell together during a 2-minute window. So if the events are in the cell outside that window, we don't care about them and they will not be correlated. The when clause just illustrates the fact that we can add additional selection criteria for our correlation. In this case, we're expecting the second event to be in an open state. If the second event came in and then was closed, and then the first event came in within 2 minutes later, and the second event was subsequently opened during that same 2-minute window, a correlation would occur under that condition as well. The code we have reviewed so far ensures events that meet this criterion will now be correlated. However, it does not make sense to correlate events and then do nothing. If you are not going to do anything with the correlation, why would you correlate the events in the first place? The section you see here defines what we want to do when events that match the correlation criteria above arrive into this cell. In this example, we are taking specific data out of the 2 correlated events and generating a new third unique event. The new third unique event will include data we have selected and concatenated with literal text. The selected data is coming out of the first 2 correlated events. The concatenation allows you to take literal text and concatenate it with values extracted from the events. In our case, we're looking at the host name here, another literal string, the MC object from the first event, another literal string, and concatenating that with MC object of the second event, followed by another literal string. The whole process of the concatenation here forms what we're going to use to populate the message slot in the new event. Before it can be populated, though, it needs to be put into another variable. And the variable we've defined here, another arbitrary value. The next step is to actually generate the new event. And that's what the generate_event command does. Our new event will be placed in the patrol event class, and its host name will be the same host name from the first event. The MC origin for the new event will be MC origin from the first event. The date will come from the first event. The MC parameter will come from the first event. Message, the message slot that is, will be populated with the concatenated string that we created up here in the concatenation function, and so on. You could take other actions in this section if you need to. For example, you could initiate the execute command to run an external program. This capability is unique to event correlation rules compared to using policies. The capability to generate a new event or execute other processes and operations is not available in the correlation policies or probable cause analysis. Processing events using rules is also less resource intensive than using policies. This example correlates only 2 specific events. However, you can correlate multiple events from multiple event classes if needed. You could also add multiple rules in this rule file. Before we can compile this rule file, we have to add the name of the rule file to the .load file. As you can see, I have already added the correlate rule file name to the .load file. Also notice that there is no .mrl extension for any of the references to the rule files in the .load file. Now let's go compile this and see what happens. Here is the command that will compile the entire knowledge base for this cell. The -v provides verbose output because I want to know if anything goes wrong. Let's run this and see what happens. As you can see, the compile completed successfully. This does not mean that my rule file is going to actually work. What it does mean is that I have no syntax errors and no errors related to non-existent event classes, data classes, and so forth. The next step is to load the newly compiled file into the cell so that the cell can act upon it while running in memory. There's a couple of ways we can do that. One is to load it with a command line utility without having to stop and restart the cell. A second method is to stop and restart the cell. I like the stopping and starting method because that ensures that the cell is healthy when it comes up and starts properly. So let's go do that. Okay, so our cell has come up healthy, and our next step is to go test the events. As you can see, my cell currently has some events already in it. When I am testing new rules that I have just compiled, I like to start off with a clean, fresh cell. This helps ensure that the test is valid and that I'm not confused with any extraneous events that are left over in the cell. So let's go clean out the cell. That can very easily be done with an mquery command with the -s delete option. And it runs very quickly, as you just saw. So let's go refresh the GUI to make sure there's no more events in this cell. And now we can go stop the services for our test. So we'll scroll down here and stop the remote registry service and the Windows Update service. Now it will take a few moments for Patrol to actually pick up those events and then for them to be populated into the cell. Okay, so our events have arrived in the cell, and we can see 2 events for the remote registry and 1 for the Windows Update service. The reason we have 2 events for the remote registry service is Patrol is set up to automatically restart it if it goes down. And that's why you see the red alarm here has been closed automatically by the incoming OK event, which was generated when Patrol restarted the Windows Registry service. On the other hand, the Windows Update service is still in a critical state because it has not been restarted, and I've deliberately configured Patrol so that it would not restart the Windows Update service. I wanted to do this to illustrate the fact that in spite of one of the events having been closed, we can still do a correlation properly. The last event you see here with the object name is-1hm, which happens to be my cell name, is the newly generated event from the correlation that the rule created for us. Notice the contents of the message slot were populated with the results of the concat function in our rule. In addition to this, if we go over and look at the internals data, for internal data we see the value 2665 here is actually the event ID. It's the internal event ID for this specific event. Notice also that there's an ID down here for causes, which is actually a different number. This 2663 is the causal event ID associated with the remote registry event and tied to the Windows Update event. So if you remember me discussing earlier in the video the cause and effect relationships, you'll see here that the cause relationship for the Windows Registry event was this event ID 2663, and in addition to that, when we look at event ID 2663 as we are now, you'll see effects data put in here, and the effect data is associated with the events from the correlation as well. So 2665 is actually the OK event that was tied to the Windows Registry restarting, and the 2662 is associated with the critical alarm from the remote registry event. So correlation rules can be very powerful and flexible, allowing you to correlate almost any conditions necessary. The example I showed you in this video is a very simple example. And that's great, and they're very powerful. However, please remember that they require coding and they can be expensive on performance if used extensively. Also remember the other methods of correlation available in BPPM that were mentioned at the start of this video. Use the appropriate methods for your needs, and also please review best practices for deployment and scalability if you haven't already done so.
That concludes this how-to video. You can find more information on BMC.com. Thank you for watching the video, and thank you for using BMC products.